turbo engine running.
Absolute genius.
Get this.
Welcome.
This is the show where we bring you
Science.
What that essentially means is
discoveries,
Advances.
Questions. Research.
technology.
Unbelievable.
Without further ado,
This is The Naked Scientists. Hello, welcome to The Naked Scientists. This is the show that brings you the latest breakthroughs in science, technology and medicine. I'm Chris Smith, and this week, take a brisk daily walk and take 25% off your mortality rate, the northern and southern lights and why they've been so pronounced of late, and have scientists discovered the world's first Roman sex toy.
The Naked Scientists podcast is powered by ukfast.co.uk. "11 minutes a day of moderate intensity physical exercise, that's 75 minutes a week, is sufficient to lower the risk of heart disease, stroke and some cancers by nearly 25%. Now that's according to a study that's publishing this week in the British Journal of Sports Medicine. The author, Soren Brugger, from the MRC Epidemiology Unit at the University of Cambridge, is here to explain how they found this and what it means in practical terms. How did you find this, Soren?
We summarized the results from nearly 200 studies that included nearly 30 million people, studies that have already been published. All the studies had at least 10,000 individuals in them, and they were all prospective. And then we put all the measures of physical activity on a common scale so that we can establish the relationships between physical activity and these health outcomes. And that allowed us to calculate the risk associated with any level of physical activity.
Now, when you say moderate activity, I'm glad you mentioned this sort of scaling, because I was going to ask you what constitutes moderate physical activity, because that can mean different things to different people. For some people, it's getting up off the sofa to reach for another biscuit, whilst for others, it's climbing a mountain. So how do you judge something to be moderate, intense physical activity?
Generally, we would consider activity that is associated with an elevation in heart rate to be moderate, and it will elevate your breathing as well, but it won't necessarily get you out of breath. If it also gets you out of breath, we start calling it vigorous. So that will also be beneficial for health, of course, but you will spend the same amount of energy faster. So these 11 minutes that you mentioned in your introduction, you could actually accumulate the same amount of energy above your resting level in even less time if it was more vigorous.
So you could take a brisk walk, or you could run up the stairs. One would have to last a bit longer than the other in order to get the benefit, but it's doing the physical exertion that seems to confer the benefit.
Indeed, and the take-home message is that anything you do is going to benefit your health, and it really does keep on giving. So the risk of these outcomes keeps going down.
How do we know in studies like this that it is the exercise that is conferring the benefit, and it's not that if you go and find people who are already active and they're active because they're well, and you measure them, you say, well, they're healthier than these people who are in bed laid up with chronic diseases? And you're saying it's the activity that's doing it. It's not that people who are already fitter are just more active. How do you control for that?
So this is an issue that we call confounding. And the way that the individual studies would have control for that is that they would either have excluded everybody at the beginning of their studies that had serious chronic disease, or they would have tried to control for it in their statistical analysis. We took the most adjusted results. So our results are actually the most conservative estimates of these health benefits. It also includes, for example, adjustment for obesity, which arguably is at least partially on the causal pathway between physical activity and some of these diseases, certainly heart disease.
So really is the sort of message and your motivation here to say to people, don't be deterred by the fact that people say you've got to be out of breath and running a marathon each week to get a health benefit, that really every little helps where this is concerned?
Certainly, every little bit helps. And it's important for people to consider their life circumstances. So 10 years ago, I might well have gone to the gym, but that doesn't quite work for me anymore. But now I cycle to my workplace because that works for me right now. And we all have our circumstances that change, but we must adapt. But we must remember that every little bit we do for our health in terms of being active, it will actually result in some benefits over time. The public health recommendations is 2.5 hours a week of moderate intensity activity, but that is a good target to build up to. But if you do absolutely nothing today, that might seem a little bit far away. So our results are incredibly encouraging that just doing that little bit will result in quite substantial health benefits.
That's Soren Brugge from the University of Cambridge. The astronomically inclined among you have no doubt been aware of the aurora borealis, or northern lights, that have been happening across the UK very recently. As the name suggests, the northern lights usually only occur in the far north, particularly in Scotland, and even then, only periodically. But this week, some dramatic auroral displays have been seen as far south, even as Cambridgeshire, with some stunning images coming from the Fens just 10 minutes from where we're sitting. So what forces are behind such a majestic phenomenon? And why were they so far south this time? To guide us through the furore of the aurorae is ex-NASA intern and guide at the Griffith Observatory, Rosemary Williams.
The aurora borealis, or northern lights, are one of the most beautiful sights on Earth. Dancing patterns of greens and reds in the sky have inspired a millennia of folklore. The Norse considered them to be earthly manifestations of their gods. Some indigenous groups considered them to be a bad omen, and were you to whistle underneath one, you would be noticed and carried up into the sky. The northern lights are typically found in the Arctic Circle. This area doesn't encompass much land. It's too far north for even Iceland to be inside of it, which makes seeing this event a somewhat rare occurrence. However, auroras over the past few days have been seen as far south as Cambridgeshire and Shropshire. So what causes an aurora to form, and why was this one so much more widespread than normal? Auroras happen when the sun sends out a solar flare. This is a million-mile-an-hour wind that is full of charged particles called ions. These ions hit Earth's magnetic field and interact with the elements that are high up in the atmosphere. Earth's magnetic field usually does a pretty good job of protecting us from these high-energy particles, except at the poles. See, our magnetic field is sort of apple-shaped. The magnetic field turns in towards the Earth at each pole and can actually funnel these charged particles toward the northern and southern intersections. Auroras are pretty much a daily occurrence at our magnetic north and south poles. These ions cause the electrons in these elements' outer layers to temporarily jump up to a more excited energy level. When these electrons return to a more stable state, they release energy in the form of visible light, anything from dark reds to light greens. Green and red light occur when low and high altitude oxygen interact with these solar particles, while blue and purple light occur when nitrogen interacts with these particles. But what was special about this one? Well, the ions involved in this aurora left the sun via a coronal hole. This is different to a regular solar wind because it reaches out further into space and pushes the charged particles out at a higher speed. This means the Earth gets hit with a greater amount of solar activity than usual. Not enough to send our satellites crashing down to the ground, but enough for ions to congregate in our atmosphere at a lower latitude. So that's why the skies were red over Cambridge, and the news looks good for any keen aurora watchers as we're entering a time of high solar activity. So keep your eyes skywards, just remember not to whistle.
Good advice from Rosemary Williams. Thanks for that.
The Naked Scientists podcast is produced in association with Spitfire, cost-effective voice, internet and IP engineering services for UK businesses. Find out how Spitfire can empower your company at spitfire.co.uk.
Music in the programme is sponsored by Epidemic Sound, perfect music for audio and video productions.
You're listening to The Naked Scientists with me, Chris Smith. Still to come, archaeologists uncover a 2,000-year-old Roman sex toy. In 1884, the psychologist William James argued that, contrary to prevailing wisdom, our emotional reaction to a situation is a result of our physical reactions. We feel sorry because we cry, angry because we strike, afraid because we tremble. he wrote. If he was writing today, having just read a paper out this week by scientists at Stanford University, he would possibly also have said, "We feel anxious because our hearts are beating too fast." By using a clever trick that involved making heart cells sensitive to light shone into the body through the skin, Karl Diceroff can increase the heart rates of lab mice and show that when their heart rates are higher, the animals display exaggerated signs of anxiety in stressful situations compared with when their heart rates are lower. This is reflected by increased activity in brain areas that are known to be linked to anxiety symptoms. Critically, it gives us an insight into how interventions like behavioural therapies and even relaxing pursuits like yoga can help to manage anxiety disorders. Drop the heart rate and you reduce the drive to the brain's anxiety pathways.
There's a surprisingly large co-occurrence of cardiac problems like fast heart rhythms, tachyarrhythmias, and panic disorder. And nobody really had an explanation for this.
How did you try and probe that?
With the technology we developed called optogenetics, we can use light to turn on cells, and in this case, the heart muscle cells themselves. And we do this by introducing a gene, a bit of DNA, into the heart muscle. And this DNA directs the production of a very interesting protein called a channel rhodopsin. This is a protein that we borrowed from microbes that receives light and opens a little pore, a hole in the membrane of the cell, and lets charged particles or ions flow across. We can put the gene for these proteins into one kind of cell and deliver light, and then we can have a direct, specific, primary effect on just the cell type that we're interested in.
So let me guess then, you did that. You put that genetic construct into heart cells so you can then shine a light on the heart cells and make them beat faster.
That's correct, exactly.
What did you do this in?
We did this experiment in mice. They have a mammalian heart and a mammalian brain. They have anxiety-related circuitry, and they do this using many of the same brain structures as we do. But we still had to advance the technology a little bit because this was a new challenge, targeting the heart. We'd done a lot of optogenetics in the brain before. The brain doesn't move that much. It's not a big beating organ. With the heart, there's so much movement. To cause a synchronous contraction, we really had to deliver light across the organ itself. We solved that. We fitted the mice with little vests that had LEDs in them, and the mice could run around freely, and we could still use the LEDs to pace the heart at the rate we wanted.
So the mice get a glowing vest that you can
That's
turn
right.
on. It's like John Travolta, but for mice.
Yes.
And you can turn this on and off and therefore change their heart rate. Does it change by much when you do this?
Well, we can change it as much as we want. Mice, normally their heart rate beats about 600 to 660 beats per minute. But when they're anxious or fearful, it goes up, and we could set the rate at whatever we wanted. We could set it at 700, 800, or 900 beats per minute. And most of the paper we worked on 900 beats per minute.
So you've got mice that you can artificially escalate the heart rate by a substantial amount. Does this produce a behavioural change in the mice?
That's right. We first asked, does the mouse seem to care? And so we started with a very simple test. We let the mouse move freely between two chambers that were not threatening, not anxiety-provoking. There was nothing different about the two chambers except whenever the mouse was in one chamber, we would elevate the heart rate. And the mice didn't care. But then we put the mice in anxiety-provoking situations. And so mice are very averse to being out in the wide open where it would be easy to prey upon them. So then what happens when you pace the heart higher? Well, the animals much preferred being protected when the heart was going faster. So they more strongly preferred the enclosed areas and the corners and the walls.
And do you know where in the nervous system the outcome was centred? Where in the brain were they altering their activity in response to heart rate changing, and that was provoking this anxiety response?
Well, that was a big open question, and so we tackled that next. And we saw a couple areas that did go up in activity. One was the prefrontal cortex, and this is involved in long-term action planning, what we call executive function. Another part of the brain, called the insular cortex, also was activated by the cardiac pacing. And this was also very interesting because this site is known to be a part of the brain that receives a lot of what we call interoceptive information that comes back from the body. So these were two very interesting regions that we saw were activated by cardiac pacing.
Do you know how the messages get from the heart to places like the brain's insula so that it can respond? Is that through the blood, or is there a nerve connection that's doing that?
There is a nerve connection called the vagus nerve that comes from the brain, exits the skull, and it innervates all kinds of organs in the thorax and abdomen, including the heart, but also the gut, but also brings information back. And the vagus nerve is just a synapse or two away from the insular cortex, and so that's a very plausible route for information to flow.
What now are the clinical implications of this?
We see this all the time clinically, that there are patients with elevated heart rate and altered mood or anxiety states. These patients are typically treated with conventional anxiety medications that target the brain, but they have side effects. They're strong medications, and they're not perfect. An implication of this study is that actually there's another opportunity that we could pay some more attention to directly reducing the heart rate as a way of improving psychiatric symptoms. And there are plenty of interesting medications that would be helpful for this, that don't affect the brain, would have less side effects, and that could well help patients with their anxiety. And it's plausible too, because we know that many relaxation methods, cognitive behavioral therapies, many of these focus on having people try to achieve a direct control over their breathing rate. Although we know these help, we've never known these work through an initial primary direct effect on the body. And this might help us treat patients more completely.
Fascinating, isn't it? Carl Dijsselroth there, and that work has just been published in the journal Nature. Back a couple of millennia now, because archaeologists have announced that they have found what they believe may be a Roman sex toy. The 2,000-year-old carved wooden object was originally discovered in 1992, preserved in oxygen-poor sediments in a ditch at a Roman fort along Hadrian's Wall. At the time, the field identification made in a hurry on the uncleaned specimen was that it was a darning needle. This was sent for conservation and put into storage. But now, 30 years later, scientists have been going through and reanalyzing some of those old finds, and this one in particular, for reasons I can't fathom, caught their eye. Based on appearances alone, its purpose looks pretty unequivocal. But there are a range of possibilities, including that it served a number of different roles in its lifetime. Newcastle University's Rob Collins takes up the story.
This is a carved wooden object which resembles a penis. So within archaeology, that's the sort of thing that we would describe as a phallic object from the Roman period, found inside the fills of a ditch outside the Roman fort of Vindolanda. It fits within human life size, scale and variety.
So what's your interpretation?
Well, we have three most likely identifications of the object, but we really can't be sure of any of them. Let's first start with a description of the object. It is about 6.5 inches long. It is carved with a knife or a simple blade from a young branch of ash. I'm sure you can imagine a phallic shape in terms of the shaft and the tip, or what's better known as the glans. That's about 4 inches of its length. The last 2 inches are what we would call the base, and that's a thicker cylinder, which has a domed end. When we looked at the object in detail, we found differential wear. There are locations on the object which are smoother from repeated friction, but they're not even or equally distributed on the object. There's smoother surface areas at the tip and to one side of the shaft, and also the cylindrical base is more smooth, but particularly the domed end is also very smooth. If you think about what that means in terms of how it was used, the question you ask is, why is it smoother at both ends than it is in the middle? And that's what led us to these three possible interpretations.
And what interpretations are they?
So the first one is that it's a separately carved phallus that's added to a larger object. In this case, we think that would most likely be a statue or even possibly a building or a post, something in the Roman world known as a herm. And so there are reasonable parallels for all those uses of a separate phallus being added. There is a wooden kind of statuette, carved statuette from a shipwreck in the Mediterranean, and we have the statuette, but we don't have the phallus. But there's a socket in the statuette where the phallus should be placed. With buildings, there are plenty of photos from Pompeii. You get some that are fully sculptural in 3D and standing proudly out from the building.
What's the second possible interpretation?
So the second possible interpretation is that it is a pestle, like a mortar and pestle set for grinding up food, perhaps to make ingredients for medicine, or even cosmetics, because people would make their own cosmetics, their own makeup in the past as well.
Do you go along with the possibility is that it's that? Because when you do those sorts of grindings, would you not expect to see material that's been ground being forced into the wood, and therefore you change the colour, you change the patterning, or would that not preserve?
That's a really good point. The use of it as a pestle would really very nicely explain the very smooth domed base, that repeated contact. It would be great if we could see examples of those, whatever ingredients, materials were being ground up. But unfortunately, the conservation process that was completed back in 1992 means we can't do any of those sort of scientific analyses for biological traces.
And what's the third possibility?
The third possibility is that it is a sex implement, what we would more often call today a sex toy. Now, calling it a sex toy implies that it's used for pleasure, and that very well might be the case. But sadly, one of the things we also have to remember is that society was very unequal, and that such an object might not only be used for pleasure, but could also be used to perpetuate a power imbalance. Women did not have equal rights. Children did not have equal rights. There were many people who were not protected under law.
When you say this was preserved decades ago, well, where's it been in the time since?
In the early 90s, in 1992, when the object was first excavated at the Roman fort of Vindolanda, they were in this fort ditch. These objects come out of the ground mucky, covered in a kind of a clingy, sticky, clayey sort of stuff. So I suspect that this object, along with hundreds of others, was recovered. It was then rapidly cleaned and then put into conservation right away so that it didn't deteriorate further. Whomever it was that looked at it and entered it onto the sheet called it a darning tool. And I can see why. There's there's the domed base, which is something you would see in darning. There's also what we now call the glands or the tip, but many darning tools have a slight mushroom shape to them. And so it's an easy ID to make.
So what prompted you and your crew to go back and look again?
My co-writer and collaborator on this paper, Dr. Rob Sands at University College Dublin, is an expert in the archaeological use and preservation of wood. And so he's been working on a long project researching the wood archive, the wooden object archive at Vindolanda. And so he's the person who, in working methodically through the archive and looking at every object, came across this one and said, this is a dick.
You certainly got a sense of humour because you titled the paper Touch Wood. But the pair of you.
Yes.
How are you going to try to resolve? Because you've set 3 scenarios there. I mean, you're saying, look, it's clearly not a darning needle. There's other possibilities here. But how can you resolve this? Or is it going to remain it's one of these 3 possibilities going forward?
I think, at least for now, and very specifically with this object, we might never know. And I think it's really important that we're honest about that. Where I think there's room for improved understanding in the future is if more objects like these are found, if some other museum curators are able to dig through their stores and say, I thought I had something similar, and something comes to light, maybe that will have the opportunity for scientific analysis. This might be the first such object, but I fully expect that more should be discovered. It's just a question of looking.
Rob Collins, and that discovery has just been published in the journal Antiquity. It's an open access publication, and the pictures really are quite compelling if you want to go and take a look. And you can certainly see why a diagnosis of darning needle just doesn't cut it. To the world of pet tech now, and the fortunes that some will inevitably spend on keeping their furry friends safe and sound. From feline Fitbits and doggy GPS devices to automatic food dispensers and ball launchers, people are going for these gadgets in a really big way. They let your pets in and out, they track where they go so you can get them back, they tell you where they've been, and so on. But many of these devices have lax security, and unsurprisingly, many owners might not realise quite how lax. The result is that they can open a cyber criminal-sized cat flap into your life, sharing personal details, including where your pet, and hence you, live, and when you're not at home, for instance, because you're out walking the dog. These gadgets are part of a rising trend known as the Internet of Things, physical objects armed with sensors, software and internet access, which, convenient as they are, can expose you to scammers and cyber thieves, as Scott Harper explains to James Titko.
So with these devices, they're obviously going to be collecting the pet data, so things like the pet's name and other information, pet photo. But in terms of the personal information that they collect, there's the information that the user will be directly inputting. So things like their address, their postcode, potentially their house number, their name, their phone number, email. But there's also the information that will be captured less directly by the user, so not inputted by them, like their location with these GPS devices. Because they're tracking the user's location if they're alongside their pet, they can, for instance, have their past routes as well as potentially their routine.
Yeah, I can see why that would be dangerous. And so is the security particularly worse in these pet apps than in other third-party apps that you might download from whatever app store?
It's possible that they're not being designed with the same security and privacy needs of other devices where human users are going to be in mind in the design process. So as we found in our study, there were vulnerable apps showing the users' login details. But we also found that users were taking far fewer security precautions compared to their general security and privacy.
That's interesting. What do you put that down to, that people are less resistant to giving over their personal information when it comes to these pet apps?
Yeah, so looking at the sort of advantages that we found from the users that they discussed, we think that maybe the users are more likely to focus on the safety, convenience, or the peace of mind, sort of the advantages that these technologies can bring to their pet. So they're focused more on the safety of their pet with a GPS device, as opposed to thinking about their own personal security or the privacy of their data.
Right, so these products play on people's emotional attachment. Well, maybe that's a bit nefarious. I'm thinking they're a bit more nefarious than they actually are, but people are less cautious because of their emotional attachment to their cats and dogs, whatever, and that's what might leave them more vulnerable. So how are criminals then exploiting these vulnerabilities? Remind us, talking in more general terms in cybersecurity, what the risks are.
So their username and password. So in this case, if an attacker were to gain access to your username and password, they have access to obviously this application and any of your personal information that may be inside here. But also it may enable them to gain access to other applications where you're using the same username and password, although recommended against, I feel like a lot of people will be doing. And the apps we looked at also revealed additional user details in plain text. So the two examples we had were one being their exact address and the other their estimated latitude and longitude on opening the app.
So I suppose the advice here for all those dog owners who that must-have gadget, automatic ball chucker, they must have it. How should they be making sure that they're being safe?
Yeah, so generally it's just to try to make sure you're following the same sort of security, privacy practices you would with regular devices and devices more focused on yourself. So for example, some more general tips, they could always try to use unique and secure passwords. Where possible, check the settings of the app or device and consider what data they are sharing and what data you want to share. So there are a few guides available, such as Mozilla's Privacy Not Included project, which does actually have a pet technology specific section with a few different devices there. So there's an automatic feeder, an activity monitor, and it tells you sort of whether their security is up to standard and some of the data they collect and whether they share it with third parties.
Scott Harper, he's at the University of Newcastle. That work was presented at a recent symposium. That's it for this week. Now, just before we finish, we've had an email from Mike who wrote in to say he was very interested in the episode we produced recently on nuclear fusion, but he wanted to ask why discussions about fusion always seem to focus on experiments that try to force fusion to occur with very high temperatures and pressures. We rarely have any discussion, he says, about the possibility of what's known as muon-catalyzed fusion that's been known to occur at reasonable temperatures and pressures. So surely this, he says, is much more practical. Well, we put Mike's email to Brian Appleby, who appeared on the programme All About Fusion. And this is what Brian kindly said in reply. We focus on conventional fusion, deuterium and tritium fuel at very high temperatures, because this is where the vast majority of the experimental work and investment has been directed over the last about 70 years. Based on this, we have a fairly high degree of confidence that this conventional approach works in principle, and indeed we know it works in the sun and in nuclear bombs. In contrast, muon catalyzed fusion. And muons, if you're unsure, those are heavy forms of electrons. That has some fundamental issues that have still not been satisfactorily addressed, and these include, for a start, an efficient method of producing the required muons in the first place. Addressing these issues, he argues, may be no less hard or easy than the issue of confinement of a hot plasma for conventional fusion. Finally, he says, many of the outstanding challenges for development of a fusion energy source are related to how we convert the energy of fast neutrons from the deuterium-tritium reactions into electricity. Those self-same challenges would still need to be overcome for muon-catalyzed fusion. So thanks to Mike very much for his question, and thanks very much to Brian Appleby for his answer. If you'd like to respond, comment, or offer some feedback on one of our programmes, do please send it in. It's chris@thenakedscientist.com. The Naked Scientist comes to you from the University of Cambridge's Institute of Continuing Education. It's supported by Rolls-Royce. I'm Chris Smith. Thank you for listening, and until next time, goodbye.